Scala. We are diving right into content today. There's no time to waste in this course. We got to go right into this. So let's learn Scala. These first few lectures where I'm covering Scala are going to go pretty quick because I am working on the assumption that you understand things like methods, packages, conditionals. That you understand those, and types is a little new, so we'll spend some time on that on Friday. So I'm assuming that you understand these concepts and that you just need to be introduced to the Scala syntax. And I won't dwell on the syntax too much. I'll show you, look at, here's how you do conditionals in Scala. You've done conditionals before. This is just the syntax that we use here. So the content will go fast. The examples will go fast. Once we get into brand new content, brand new concepts that you haven't seen before, which the first one is going to be testing with unit testing, then I'll slow down. Things won't go at quite a blistering pace. But for these Scala introductions, it's going to go quick. We have our first lecture objective. Today's lecture objective is lecture objective 1 from the Pale Blue Dot project. So if this doesn't make any sense at all, go check out the project, get your background. I got a typo already, which is in the PBD. That's going to be an autocorrect error. It was PBD that's supposed to say. And then I got auto-corrected to pod. The computer thinks it's smarter than me. So this is the first objective from that project. So for context, read the project, get familiar with that. That's exactly where this comes from. The first objective is to write a method in the Pale Blue Dot object, which is in the PBD package, named degrees to radians, which takes a double of a parameter representing an angle in degrees, and returns that same angle in radians by implementing this function. So the code itself here is not too complex. You're taking a number, multiplying it by pi, and dividing by 180. But there are a lot of words in here which you probably haven't heard. You might not have heard package, object, you've heard, but in a JavaScript context, method, types, parameters. Hopefully you know what parameters are. But types, double as a type. A lot of things that we need to nail down today about how to do this in Scala. And when you're done with that, zip up your whole project, submit it to Autolab, and see what Autolab says about your code. So, Scala. So by the end of today's lecture, you should be able to complete that. Whenever there's a lecture objective, the idea is that you don't know how to do that right now, but by the end of the lecture, you will be able to complete that lecture objective. So today you can get your first objective done in Pale Blue Dot, except for the testing. We haven't talked about testing yet. Syntax for pi is math.pi. Okay, so let's look at our first Scala program. Hello Scala, our very basic introduction that we always do in programming, usually hello world. Let's say hello Scala because Scala's, saying hi to us. So this program is going to print hello Scala to the screen, and it's a pretty much minimal program to be able to get that done. So let's break this down. In today's lecture, we're going to go through 3 examples, just slowly introducing more and more concepts. Let's break this down and talk about each piece of this because there's a lot more to just printing something to the screen, just writing any program in Scala than there is in Python or JavaScript. Python, you would just say print hello Python. JavaScript, console.log hello JavaScript. But in Scala, we have this package declaration and object. We got a lot of stuff. So let's break this down and talk about what's going on in this program. So first, our package declaration. All your code in a Scala program is going to exist within a certain package, which is going to hold multiple objects and later on classes contained in at least one file, possibly multiple files. This should exactly correlate to your directory structure. So this code lives in a package in the examples repo, a source package where all the code goes, and then a directory structure matching the package structure for that code. So this code lives in LO1 program execution /Scala. If you go to the examples repo on GitHub and you go to the source directory LO1 program execution Scala, you'll see a hello.scala file containing exactly this code. This is very similar. I'll tone down I used to talk about Java a lot in this course. I'll tone down the Java talk, but for those of you who have had Java, it's the same thing as Java packages. The only difference is Scala does not enforce that the directory structure exactly matches your package structure, but I still highly recommend that, as long as it makes sense, make sure your directory structure matches the package structure, or probably always. Maybe that should just be a strong recommendation. To create a new package, for the first project, you won't have to create any new packages, but if you do have to, right-click on the directory where you want the package, go to New, Package, and then name your package. But they do function the same way as Java packages. So Scala, we'll talk about this just a tiny bit later, but I'll say it right now anyway, so you won't have to wait. Scala does compile down to Java bytecode. So after Scala is compiled, it's identical to Java code. So there are a lot of similarities between Java and Scala. What's up, Serial Guy? So next, after the package declaration, which you can think of as the directory structure, defining the directory structure, but this package declaration has to be there. If I say create an object in a package named PBD, you have to have a package declaration that says package PBD. Even if you are in a directory named PBD, you have to have that package declaration there. Next is our creating an object. So an object is a container for variables and functions, which when we have a function that's inside of an object, which is going to be most functionality that we talk about, we call those methods. So this object is going to contain variables and methods, and all the code that we have in Scala is going to have to be packaged in an object or later on in classes, in objects. Every piece of functionality in our programs contained in an object. Classes are used to make objects, but that's what our object is. So we have to create an object to be able to have a Scala program or write any Scala code. So we create an object, and we're going to name this object hello. So we have an object named hello that we're going to create, and it's common practice to have your object match the file name in which this is contained. So this code is contained in a file named hello.scala in a directory structure matching the package declaration. So you can think of these package declaration and the object name saying, where can you find this code, in a sense. And I'm covering up a little bit. We call them methods when they're part of an object. So we'll talk about functions way later, but most of what we'll talk about will be methods. And next is our main method. This is the most important method for running a program, because this is the method that is executed when you run this program. So IntelliJ, when you want to run this program, you're going to right-click on the file, or there are a few ways to do it, but you can right-click on the file and click Run. When you run an object, Scala is going to look for a method named main with this exact signature. Def main args array of strings unit. It's going to look for something exactly like that with this exact string as its method declaration, and then run the body of that method. So this is saying, hey Scala, this is where my program starts. And for this example, that's all it does. So this is where the program ends as well. But the main method is where your program starts. So when you run when you run an object, you're calling the main method is effectively what you're doing. You can have more methods in here, but the one that's named main that takes an array of strings and returns unit, that's the one that's going to be executed when you run an object. You'll always, and it will always be this string like this. You can always cut and paste that identical, like that's always what it's going to be. The body of the method is going to change with whatever code you want, whatever you need to do to run your program, but this part is always going to be identical. Or else the only thing that can technically change here is args. That's the name of a variable. You can name it whatever you want, but everything else has to be identical, or else Scala won't know what you want to run. That's our way of telling Scala, look, this is where my program starts. Yeah, serial guy. I'll add to that a little bit. You just have to type main. If you're in IntelliJ, let's jump to IntelliJ super quick. Like if I don't have this main method, I just type main, and IntelliJ will be like, oh yeah, you're writing a main method, and it'll give you that exact string for you. That's so standard that our IDE just helps us out and says, oh yeah, you're writing a main method, I got you. So this isn't something you have to memorize, but it is something that does have to be exact, or else Scala doesn't know. That's just how we communicate with Scala. And that's your first Scala program. That's it. We print hello Scala to the screen with the print line method, which is automatically available to us. And that's your first Scala program. IntelliJ doesn't cost money if you either get the community edition or do what I recommend, get an academic license, and then you can download the ultimate version for free. All right, so you know Scala now. I'll pause for a little bit. Are there any questions about this example? I'll pause after each example for questions. Have you tried hitting cap locks? Yeah, we got a couple of shouters. Bad boy, you're still screaming at us. My keyboard broke, sorry. You actually have a mechanical issue with your keyboard? That's fantastic. I'm not even mad. You can still do the project if you don't have ultimate version. When we get to homework 4, I think is the only one that might be affected. You might be missing just a few features that will be nice quality of life features that'll help you for that homework. But you can get away with community the way the course is structured this semester. In previous semesters, you needed ultimate to really get things working. All right, so let's talk about methods and variables. Let's jump on to example number 2. So this program, I'd be willing to bet that any one of you can read through this code and figure out what it's going to do. This is, of course, I have the answer on screen too. This is going to print 14 to the screen. We have a number variable with the number 7. We're going to call this multiply by 2, which is going to multiply 7 by 2, return 14, and then print 14 to the screen. But I would also almost guarantee that if I said write a program that calls a method and multiplies 7 by 2, that very few of you would actually be able to do that because there's a lot of new syntax here. So you can kind of just infer what's happening here, but the syntax is new. For example, how does this method know to return 17? I don't have any return statements there. What's going on with that? So let's go through this like we did the previous one and talk about the new syntax that we're looking at here to get you to the point where you could write a program like this beyond just reading it. So first, our package and our object. This is in a file named firstobject.scala. You can find it in the repo. And you can follow along this example. You can clone it and play around with the code. Especially after tomorrow's lab, you'll know how to clone it and play around with this code. That's what tomorrow's lab is all about. So let's look at the first new piece of syntax here, a method declaration other than a main method. So this is a method that we're going to write, and we're going to call ourselves. We want to use this method in our programs after we write it. So the big difference here that you're going to notice, it's mostly similar to JavaScript and Python syntax, but the big difference you're going to see is that we have types. This is the biggest adjustment that you'll have to make moving to Scala is what's called a strongly typed language, which means the type of everything has to be clearly defined throughout our programs. So every variable, every method parameter, every return value, the types have to be defined, and we have to stick with those types. This is a promise, a guarantee that we're making with Scala that this method is going to take a double as an input, a value of type double, and return a value of type double. And we cannot break that promise. We are guaranteeing Scala, hey, we're going to do this. And if we ever don't comply with that, Scala is just not going to run. It's going to be very picky, very finicky, and saying, that's not a double, not doing it. So that's the biggest adjustment that you have to make. How to define and name a method, def, and then the method name should look very familiar. But when we get to the parameter list, we see that first type. So in our parameter list, usually in what you're used to in JavaScript and Python is that you only specify the name of the variable. Here we're still specifying the name of each parameter, of each parameter variable. We name this one input, so we take an input named input, go figure, but we also have to specify the type. The type and name are separated by a colon, so we have an input of named input, and then colon, I'm about to tell Scala the type, and then I say the type. The type of this has to be a double, where a double is a float in Python. I don't know how much, the types are so transparent, I don't know how much you've seen the types, but a double is a number that can have a decimal portion, which we will talk about a bit more on Friday. So this takes one input, and it has to be a double. So 7, when I pass this, it's going to have to be a double, which luckily it is. It has to be a double for this method to work. If we give it something that's not a double, sometimes we can be okay. If we give it an integer, Scala will auto-convert it to a double. But if we give it like a string, this is going to crash. It's not even going to run. Yeah, double's very similar to a float. It's a double precision floating point value. So we have one input. So this method takes a double as an input. Next, we have to specify the return type. For every method we write, we have to specify what it returns, what type it's going to return. In this case, this method is going to return a double. And that is a guarantee, that's a promise. Once we say this method takes a double and returns a double, Scala will hold us to that. And if we ever violate that promise that we made to Scala, Scala's not even going to run at all. So this method returns a double. Whatever we do, whenever we call this method, it's going to return a double. It's guaranteed to return a double. We have to return a double. It has to. End of story. That's a contract that we have to fulfill. To specify the return type, right after the end of the parameter list, we add a colon and then the return type, and that's telling Scala, look, this returns a double. We can see one other return type here. Unit, if you're coming from Java, this is the same as void. Unit says this method doesn't return anything. So unit just means there's no return value here. Don't worry about the return value. It doesn't return anything. It doesn't make sense for main to return anything, except in like C and C++ where it returns error codes. It returns an integer, we don't need to talk about that. So the return type, double in this case, but we have to specify the return type. And then the body of the method, we separate the header of the method, which defines the name, the input, the parameters, and the parameter types, and the return type. We separate that by an equal sign to the body of the method. The body of the method being all the code that's going to execute when this method is called, which just multiplies the input by 2. Very importantly, I should have moved all this text over a little so I'm not in the way. I moved it over, but I didn't move it over enough. The returned value of a method is the last expression that's evaluated during the call of that method. So whenever this method executes, its return value is the last expression that was executed. In this case, there's only one expression, input times 2. So whatever this resolves to, in this example, it's going to be 7 times 2, resolves to 14. And then we hit the close brace, the end of the body of this method. 14 was the last thing that was evaluated. 14 is the return value of that call. So this is going to return 14. There is a return keyword in Scala, but its use is strongly discouraged. The way the language and the community around the language behaves is that we don't use return values in Scala. They're optional and they're discouraged. So we don't have a return value. We could do return input times 2. It will still compile, everything will still work, but we typically don't add the return statement. It's similar to the reason why we don't use gotos. It can really mess up the flow of your program, make things harder to debug. So 14 is evaluated in this example. That's what's returned. It's always the last expression that's evaluated in the body of the method. That's what's returned. So the last thing that's evaluated in this method better be a double or else we broke that contract. So when we go to call this method, we have our first variable declaration, and we declare variables using the keyword var. var is going to say, I need a variable, and we need to, the type of a variable has to be specified. Sometimes it's not specified by us, but it has to be clear what the type of every variable is. So here I'm creating a variable named x, and I'm just clearly, explicitly declaring its type to be a double. So this variable of x is type double. It can only ever store a double. I can't put an int in there. Technically I could, because it would be auto-converted to a double. But I can't put a string in there. I can't store a list in there. This variable x is always going to store a double. Its value might change. It is a variable, so the variable can have different values. Its value can change. It can be reassigned to different values. But the value always has to be a double. Always, always, always. Because it's the variable type is a double. When I call multiply by 2, I'm going to give it the variable x, and whatever value it's currently storing, which of course is 7 in this example, is going to be the input parameter of multiply by 2. So this x as an argument is going to be assigned to the parameter variable of the method, and then the method is going to execute. 7 times 2 resolves to 14. We hit the end of the method. 14 was the last expression that was evaluated. It's going to return that. It happens to be a double, which is great, or else everything would break and the world would end. And this resolves to 14. We're assigning that to a new variable named result, and we did not explicitly declare the type of result. So this could be bad if we don't explicitly declare say what type this is. We can get in trouble. We might get errors here. In this case, Scala works for us. Scala works with us quite a bit, actually. Scala is going to say, look, you didn't define the type of this, but look at multiply by 2. You absolutely guaranteed and signed a contract and said multiply by 2 is always, always, always going to return a double because you told me that that's its return type. So Scala's like, well, there's no other choice for result but a double. Result has to be of type double because you're assigning it the result of a method that returns type double. So Scala actually works with us and infers that the type of result can only be double. That's the only choice. So it creates a variable of type double for us. We could, and I usually do, and I'll stick with this in most of the lecture examples, I'll skip the inference and explicitly declare what the types are, just for clarity of the code. And I recommend doing that as well in your code. But in this case, I didn't declare the variable type, but Scala was able to infer it based on the return type of what I'm assigning to it. Same thing here if I left off this double. Well, 7.0, since I added the 0.0, this is a double. If I just said 7, it would be an int, and I would get in trouble here. But since I did 0.0, it would infer, Scala would infer that this is a double. But if I said var x equals 7, it would infer that to be an int. I would try to call multiply by 2. Actually, it would auto-convert to a double in that case too. But it's sometimes hard to get in trouble with that because Scala helps us out a bit. But we would be given an int to a method that takes a double. And, things could be unexpected behavior. So, but if we say, no, this is a double, even if I said x of type double equals 7 without the 0.0, it would still be converted to a double. And that's it. Any questions on this? I'll try to catch up with some of the chat. I think a lot of the questions that were asked were answered in chat. I have a few slides on doubles in Friday's lecture. And when we start talking about testing, I'll go into it further. But very quickly, it's a 64-bit floating point value. So it's we have 64 bits to store a value with a decimal portion. Whereas float is the same thing but 32-bit. And I think a Python float is actually 64-bit. So it's the same thing as a Python float. Or I guess there's no corollary in JavaScript. JavaScript only has number, which can be integer or double, and it auto-converts. It does a whole lot of magic behind the scenes. Is x equal to input? Yeah. Oh, yeah. So when this method is called, there's this invisible line. I talk about this a lot whenever I teach 115, but there's an invisible line of code whenever you call a method that says parameter equals argument. So there's an input of type double, which is actually a val for this invisible line. Val input of type double equals x, and x resolves to 7. So input gets the value that's stored in the argument variable. So input would be 7 in this example. If we change this to 6, then input is going to be 6 in that example. Scala methods are the same as functions, right? So a method is the same as a function, but it's contained in an object. Once a function is contained in an object, we call it a method. Across all languages, it's programming, just part of the programming lingo. Yeah, I'll go over IntelliJ setup quickly. I mean, I won't have a ton of time today, but I'll at least go through a really quick example. Stop the kiss, please. Either Bad Boy's a really good troll or his keyboard is actually broken. He claims it's broken, but I think he might just be on next level trolling. We'll see. Time will tell. Yeah, just hold shift, my dude. All right. One last example. My ears hurt from the shouting in all caps. All right. Conditionals. Let's do one last example today. A little bit bigger example, but nothing too new that I get to talk about in this one. Mostly just reinforcing what you already know about conditionals. So I do sneak in a few other things, but let's go through this. Again, I'd be willing to bet that you can read through this code. I'm printing out this method with an input of 70, 50, and 10. And I have cutoffs to consider something to be large. It has to be greater than or equal to 60. For something to be medium, it's greater than or equal to 30. If it's less than 30, then it's going to be small. It's just going to return that string and then print those to the screen. So it's going to print large, medium, small. I'm sure you could read through that and infer that that's what's going to happen. But let's talk about why and how that happens and get you to the point where you could write something and use these concepts, write a Scala program that uses this stuff. So first things, I snuck in this keyword val instead of var. So I'm declaring, looks like I'm declaring variables, except I used val instead of var. What val means is instead of a variable, I'm declaring a value, and a value cannot change ever. Once I say val large of type double equals 60, large is always going to have the value 60. Forever and always, it cannot change. The value stored in large cannot change. The value stored in medium is always going to be 30. It cannot change. So usually when a value shouldn't change or isn't going to change, we'll use val to make it clear that, hey, this is never going to change. And that way, if we do accidentally try to change it, we're going to get an error. And Scala's going to be like, hey, you said that wasn't going to change, but then you tried to change it. Like, maybe you should rethink what you're doing here because something doesn't seem right. And then we can go, oh, yeah, I didn't mean to change that. And then you can fix your code. Helps you debug quite a bit. And it allows Scala to optimize your code a bit more. If it knows these are never going to change, it can do some more fancy optimizations. Make your code run, slightly faster. Not enough to notice in this class, but it's good practice, good habit to get into now. So values cannot change. Vars can. Variable value. Variable is variable. Value is, cannot change. It's always going to be the same. And then our conditional. So the syntax, I really don't have anything to talk about here because it's identical to JavaScript syntax. You have if, and then in parentheses, or Java. No matter where you're coming from, you've probably seen this, unless you've only seen Python. So if, and then in parentheses, a Boolean expression. If that Boolean expression is true, execute the code in that block for the conditional, and then skip to the end of the entire conditional block of the entire statement. If it's false, go to the next thing. This is an else if, so if this is false, move to this one, check this conditional, check this Boolean expression. If this is true, run this one. If it's false, go to the else, and then run this. This executes if both of these expressions are false. If this one's true, return large, or the value is large. If this is false and this is true, return this. If these are both false, return this. Difference between colon and and. Colon is usually to specify a type, and equals is an assignment. We're saying this method is going to be this. Like, this is what this method does. So the syntax for a conditional you're all familiar with. Indentation doesn't matter. That's a big point for those of you coming from Python. The white space doesn't matter in Scala. We use braces to specify the start and end of code blocks. The indentation does not matter. You should still have good style and be consistent, but the language doesn't care. So the syntax of a conditional is stuff you're familiar with. So I don't have much to say about that. But I did set this up in a strange way just so I can talk about, re-emphasize a point that we just talked about. Is the last, how does this method know what to return? And that's, going back to the other point, the method returns whatever the last expression that was evaluated was during the call of that method. So here, depending on this conditional, the last expression that's evaluated is going to be different. So if this is true, if input, say the first call, input is 70, which is greater than 60, this will be executed. Large will be executed. That will end the conditional, and that takes us right to the end of the method. So when we hit the end of the method, the last expression that was evaluated was just the string literal large. So large is what's returned in that case. And we have return type string, so we had to match that. Luckily, that was a string. We returned a string. If this is false and this is true, medium, end of the conditional, end of the method. Medium was the last expression that was evaluated. So we return medium from this method. And then likewise for small. So we're using a conditional to determine what's going to be returned from this method. And there are a few ways to do it. I did it this way just to emphasize this point. You could say var return value of type string equals something like empty string or a default value of whatever you want. And then if input greater than equal to large, return string, return value, I forget what I called it, equals large, return string equals medium, return string equals small, and then return string on the last line. We can do that in different ways. But I wanted to show off this way of doing it. There is a caution that I have to give you for this. If you don't have an else, this will give us an error. So we have a guarantee that we're returning a string, and we have a conditional that Scala doesn't know. We don't know when this method is called, which branch we're going to take on this conditional. So every branch that's taken has to return a string, has to result in a string being the last expression that's evaluated. So we do have that here because we have the else, which catches everything. But if we did else if input less than medium, small, then we're going to get an error because there's no guarantee that the last expression that's evaluated was a string, because what if all the conditions are false? What do we return? And Scala's gonna give us errors with that and not run our program. Which brings us back to the lecture objective. You have everything you need to be able to do this, but we go to 2:40. I always forget with these times being off the hour. We have till 2:40. All right, I can do some good examples here. So let's go to IntelliJ and set up a project. I'll make this bigger in a second, but I want to I don't know. It makes sense. Trust me on that, I guess. So if we want to start a brand new project, which for this course I actually I'll give you the starter projects for each time you have to write code. So to start a project, new project, go down to Scala and IDEA, assuming you already have everything set up. So follow all the links from Monday's lecture on the schedule. Go to Piazza if you need any help. There's a post from a TA, explaining exactly how to get IntelliJ set up to the point where you can run Scala programs. So if you don't see Scala here, go through that procedure again, make sure you have everything installed properly, or come to office hours, or ask us in lab tomorrow. IDEA is going to give you the same structure of projects that I'm going to use throughout the semester. Next, we're going to give it a name. I don't know, lecture example. And you're going to choose the versions of everything. We're using Java. Oh my goodness. I didn't set it up on this laptop yet, or on this desktop yet. So this is even better than what I was going to show. So we're using version 12.13.4 for Scala. So I'm going to tell this to download real quick while I catch up on chat. You show us from the beginning how to start Scala. Yeah, depends what you mean the beginning. I'm not going to start with installing IntelliJ. All right, so we have to 13.4. I'm going to finish this, which gives me a brand new project with a source folder. If I expand these directories, I have a source folder. And I have the wrong version of Java. So if you have the wrong version of Java, we're using Java 15 in this course. Go to File, Project Settings. I clicked the wrong thing. File, Project Structure, SDKs, add a JDK, and this is in the... Oh, you know what? I didn't update my IntelliJ either. For those of you who took this last semester, you have to go through the same stuff I have to go through after today's lecture. Is update to the latest version of IntelliJ is the easiest way to do it. The latest version of IntelliJ, when you click this plus and JDK, it'll give you an option right here to download Java 15, so you don't have to mess around with the Oracle website and things like that. But 15 is the one that we're going to use in the course. But once you have your project set up, you have an SRC folder. You can go to New, Package. Oops, fat fingered that. New Scala class, and you can go down to Object. We're going to be creating objects for now. And IntelliJ will set up all the structure, the package and object for you. Use our main shortcut. Write my beautiful method here. And at this point, actually, I can switch over. Oh, no, let me not do that yet. And then when we want to run a program, we're going to right-click. There's a few ways to do this. You can click these green arrows, or you can right-click the object that you want to run and go down to Run. That's going to run your program, run the main method of your program. It's going to take a while to compile. You'll notice this takes a while as compared to Python or JavaScript, because this is what's called a compiled language. The language compiler will look through your entire program and do a lot of work to convert it to Java bytecode, and then run your program. And we get our program executed. Once you run your program once, you can use this shortcut up here to run the last object that you ran, to run that again. And it'll go a lot quicker the second time because it doesn't have to compile again. So let me go through an example that you will absolutely have to go through. I'm going to go to the pale blue dot assignment, grab this repo, so I'm going to the repo and going to the code and getting the URL for the repo that I can clone. Go to IntelliJ. This is where we go to VCS for version control software, and then get from version control. I'm going to paste that URL and clone this project. Well, yes, I would like to do that. And at this point, I can switch over. And get this looking the way it's going to look for the rest of the semester. So here I have the repo cloned and in full screen mode for you. When I go to this view, you won't see the drop downs. Like if I click up here, you don't see anything. So that's why I go in the other view sometimes, just in case you're wondering. So I have the code for this repo. The first thing you'll be doing, you make sure you do, is right click this src folder. Go to and then right after I say that, I do something where I need a drop down. Damn it, Jesse. Right click the src folder and go to mark directory as sources root. This is going to tell IntelliJ that this is where my code lives, and it's going to treat that as Scala code after that. So now that I have that marked, let me go back to the better view. So once I have that marked, now I can see the handout code for the project, which gives you each method header, and then your job is to fill in the code. Like degrees to radians, today's lecture question, it's set up for you in an object pale blue dot and a package PBD. Name degrees to radians, takes a double, returns a double. All that's set up for you, and then your task is to complete that code. So if I were to write this, I want to make it wrong. I wonder if I can do it like this. Let me just do this because I'm set up for this one. So this is mostly correct, but kind of wrong. But I'm going to complete the degrees to radian lecture objective, and then once I have that, I'm feeling good about my code. I'm ready to submit, and I want to see how I did on this. Forgot there's very little actual coding that I'm doing. Actually, let me first. Yeah, let me just do it this way. So you should test this first, but we haven't talked about testing yet. So after that, I'm going to go to File. Oh man, I can't even see it. Export to zip file, and that's going to give me a zip with my entire project. When you save your zip, make sure you're aware of where you're saving it. I want it in my downloads directory in CSE116.zip. Sure. And once I have that downloaded, that's what I'm going to submit to Autolab, which I'm probably not logged into. Oh, hey, I am. All right. Go to Autolab. Go to the pale blue dot assignment. Affirm that you have not cheated on this assignment. Submit. Downloads CSE116.zip. Then submit that. And then we wait. It's going to, it takes a while, like, I want to say 30 seconds for this one to grade your assignment. But you will get your scores for that assignment with some feedback. And I'll show you the feedback and what that means as well. The repo is taking forever to clone. The repo shouldn't take too long. I don't know. Depends what you mean by forever. Yeah, lectures are typically on YouTube day of. Mike's really good about that. They'll be on later tonight. Yeah, this is not going to give a 1.0. There's a lot wrong with what I just submitted. Even with just the objective, even just the code that you saw is wrong. Yeah, I'm definitely getting a 0. And this is where students typically mash refresh. Give me my results. Try not to mash refresh too much, but how do I delete or try again? So this is my 4th submission for this. You just resubmit. You go back to pale blue dot and submit it again. You can submit as many times as you want. You just resubmit. So I submitted 4 separate times, and I get my results 4 separate times. And I even got full credit once. Twice, I guess. And this is where your learning objective right is going to be. If you get a 1 here, you've completed the right portion of this learning objective. And then the number of application objectives, there's only 1 for this assignment, but how many application objectives you got credit for. AutoLab will give you all that. It's spam F5. It should be done by now. There it is. And this is going to give you feedback. So let me walk through this. First, in case you're having some really strange issues, this will be relevant to you, is the exact version of Scala and Java that AutoLab is running. So AutoLab is running Scala 2.13.4 and Java 15.0.2. So if that's helping your debugging at all, I just want to make sure I'm very transparent. Like, this is exactly what's being ran on the AutoGrader server. Next, it's going to show you the Scala files that you submitted. So if you don't see anything here, you know you submitted the wrong file or not a zip file or something went wrong. But if you should see your directory structure and your files, your Scala files right here, expanded from the zip file that you submitted, just so you have a good idea of if submission went the way you expected. Then we get all the results. So of course this is for each objective, but let me pick apart objective 1. So first, you're going to see the results of running my tests against your code. And here I have 2 different sets of tests. The first one, test functionality. My code passed that test, and I'm happy about that, so that's good. But I failed test 2. So there's another set of tests that I didn't get credit for. And if I look, the test name is check if an estimate of pi is being used. Well, I typed 3.14, which is certainly an estimate of pi. It's not exactly pi. So since I used an estimate of pi and just hard-coded 3.14, I failed this test, and it gives me an idea of what happened there. An estimate of pi is being used. Failed test 2. I need to use exactly pi. Not exactly, because the computer has to round, but however much pi we can fit in 64 bits. That's what you should be using. So since I used an estimate, I failed that test, and I don't pass all the tests. So my functionality is incorrect for this. Next, I'm going to run your test against various solutions. First, I'm going to run your test. Since I didn't even write any tests for this submission, of course I don't have any testing, and we're not even going to talk about testing till next week, but I want to explain the feedback. I'm going to run your test, and I'll explain it again when we get there, of course. I'm going to run your test against your code and my solution. You should pass both of these. Mine passes both of those because I don't have any testing. It just passes everything. And then I'm going to run your tests against various incorrect solutions with some somewhat cryptic names. Returns a constant and uses rounded pi. My testing passed these incorrect solutions, so that's bad testing. So I didn't pass the testing for this objective either. And then way down at the bottom, you can see your score for learning objective right and the application objectives. Testing the tests, that's right. And if I go to my solution, which gets everything correct, we're going to see what that looks like. You'll have this objective complete at the end of each objective that is completely done. If you have the testing correct and the functionality correct, you're going to get this objective complete. It's confirmation that, hey, you're done with this objective. Move on to the next one. And once you get that for at least most of these, you'll get your ones.